Hello everyone, welcome to What, Why and How. This series is about probability. Let us try and understand probability intuitively with a lot of examples and very less mathematics. What is probability anyway? Every single day we are doing probability in our head without even realizing it. We are not using formulas, we are not rolling dice, we are not flipping coins, but we are constantly asking the question, what are the chances? Probability is not just about numbers, it's about how we deal with uncertainty. It's a tool our brain uses to make decisions when we don't know what for sure what's going to happen. We are constantly running micro simulations in our head. Will my team win tonight? Should I cross the road now or let the vehicle pass? Is it going to rain? Should I carry an umbrella? Every decision, every step we take is assessing probability in real life. Our gut feeling is important, but it can also mislead us, especially when patterns are involved. Our gut feeling is fast, intuitive, human, but sometimes it needs a reality check, and that's where probability steps in. We keep using words like probably, possible, rare, certain, etc. But the terms mean different things to different people. If a medical test says probably negative, what do you do? And that's the problem, especially when decisions depend on it. However, when the medical test says 5% chance that it is negative, no. Because putting a number to uncertainty and the numbers make it clear and help you make better decisions. How do you visualize probability? What does a 20% chance look like though? Let's start with the slider. Probably starts with 0%, which means it is impossible, and goes to 100%, which means it is certain. And somewhere in between is 50%, which is pure uncertainty. Now imagine a circle which is part red and part blue. Say it is 70% red and 30% blue. Now if I randomly throw a dart onto the circle, where is it more likely to land? The more space a color takes up, the more likely it is to land there. It is random but not chaotic. Based on the proportion of the circle that these colors occupy, you can easily guess the probability. Now based on this, you can easily say that if I throw a dot onto the circle, there is a 70% chance that it lands on red and a 30% chance that it lands on blue. Therefore, in order to visualize probability, in order to put a number to probability, thinking of that as a proportion is very important. Similarly, if we take the classic case of balls in a bag, if we have a bag with 10 balls and 7 of them are blue and 3 of them are red, and if I close my eyes and randomly pick a ball, the probability that it will be a red ball is 3 out of 10, which is nothing but the proportion of red balls out of the whole all the balls, and the probability of it being blue is 7 out of 10. Now there are a lot of important concepts in probability. Let us try and understand these concepts using a coin toss example. What is chance? Chance is basically a likelihood of specific outcome happening. When you flip a coin, there are two likely outcomes, either heads or tails, and each of them is equally likely. That is, there are two possible outcomes, and the probability of head is 1 by 2. Similarly, the probability of tail is 1 by 2. So both are equally likely with a chance of 50% occurrence. What is fairness or bias? Now in your textbooks or everywhere that you see, the examples that they either talk about a fair coin or they talk about fair dice. A coin is fair if each outcome, that is heads or tails, is equally likely. That is, they have equal chance of occurring. For a standard coin like we saw earlier, the chance of heads is 50% and the chance of tails is 50%. But if the coin has been tampered with, that is, if the coin is bent or if there is some weight added to one of the sides, then the coin becomes biased because the chances of heads and tails are not equally likely anymore. For example, the biased coin might have 70% chance of landing on heads and a 30% chance of landing on tails. What is randomness? A coin flip is a classic example of a random event because you can't predict the outcome with certainty. Even if you know all the physics involved, the force of the flip, the air resistance, the tiny unpredictable variations make the result unknown. The outcome is not influenced by any pattern or previous results. Of course, we are talking about a fair coin here. What is independence? Each coin flip is an independent event. This means that the outcome of a flip has absolutely no effect on the outcome of the next flip. If you flip a coin 9 times and get heads all the 9 times in a row, the probability of getting a heads on the 10th time is still 50%. The coin has no memory of past flips. If you get head 9 times, it doesn't mean that the 10th time will be a tail, because the events are independent. What is expectation? Expectation is a very important concept. Expectation is basically the predicted average outcome over a very large number of trials. Say if you flip a fair coin a few times, you might not get exactly 50% hits. Say if you flip a coin 5 times, you might get heads 4 times out of 5. That is 80%. But if you keep flipping a coin a large number of times, say 10,000 times, 100,000 times, or 1 million times, the results will get closer and closer to the expected average. The expectation is that in the long run, after a large number of trials, you'll get hits exactly 50% of the time. So what is the formula for probability? Putting a number for probability is about finding the proportions of an event in the overall population. It's about figuring the ratio between what you want to all the possible outcomes. Say die has 6 equally likely sides. If you want to roll a 3, that is just one favorable outcome out of all the 6 possible outcomes. So the probability of rolling a 3 is 1 by 6. What if I am okay with rolling a 3 or a 5? Then that is two favorable outcomes out of the 6 possible outcomes. So the probability of rolling a 3 or a 5 is 2 by 6, which is 1 by 3, 33.3%. This works for any situation where every outcome is equally likely. But what about biased situations? Imagine a die where each number from 1 to 5 has a weight of 1. However, 6 has been tampered with to have a weight of 3, which means the probability of rolling a 6 is 3 times more likely than any other number. So now the total weight of the die is 1 into 5 plus 3 is equal to 8. Now the probability of rolling a 3 changes to one favorable outcome out of the total weight of 8, which is 1 by 8, and probability of rolling a 6 is 3 favorable outcomes out of the total favorable outcomes, which is 8. So the probability changes from 1 by 6 to 3 by 8 for rolling a 6. So when we want to think about finding a probability, think of proportions. When you want to talk about probability of multiple events occurring together, that is when and or becomes important. Let's talk about this using an example of students in a class. Let's say there are 100 students in a class, of which 20 play basketball, 30 play football, 10 play both, and 40 play neither. Now if you want to find probabilities in this scenario, that is if we want to find the proportions in this scenario, it's easy to visualize in the form of a Venn diagram. Let's assume this rectangle represents the entire class of 100 students, and say this red circle represents the students who play basketball, and blue circle represents the students who play football. Now this intersection of these two, this area here, this represents the students who play both, which is 10, students. This intersection of both the events, where event 1 is a student playing basketball, event 2 is a student playing football. The intersection of these two events, which gives us the students who play both basketball and football. What about students who play neither? That is the area outside these two circles. This entire area outside these two circles are those students who do not play either football or basketball, which is 40. Now with this diagram, it is very easy for us to figure out proportions. Now if someone asks, if I pick a student at random out of the 100 students, what is the probability that he plays both football and basketball? That's nothing but 10 out of all the 100 students, which is 10%. What is the probability of a student playing neither? That is 40 by 100, 40%. What is the probability of a student playing football or basketball? Now that is a union of these two circles. The students who lie within these both circles are the students who play either only football or basketball or both. So that will be 20 plus 30 minus 10. I need to remove 10, otherwise I'll be double counting the students who play both the games. Divided by 100, which is again 40%. So again, all that we are doing here in order to find probability is finding the proportion of students who satisfy specific conditions out of the total number of students available. So when we want to find out probability, think of proportions. In the next video, let us talk about conditional probability and Bayes' theorem.